You are watching TypeScript Masterclass and we are continuing our discussion on decorators. So in previous video, we have completed class decorators and parameter decorators. In this video, we are going to look into method decorators, and with this we will be able to complete the decorator section. And as usual, all the source code links are given below in the description box, so feel free to check that out. And without wasting much time, let us start writing some code. So here in parallel to class decorator and param decorator, I'll create another file called as method decorator. Then as usual, I'll add a console.clear statement so that we'll have a clean console always to look at. Now to work with method decorator, we need a class and to have some method in that. So let us quickly write a class and some methods into that. So if you see here, I have a simple math class and I have two methods. These are static method. So add and multiply. So we have already discussed the concept of static. So what we can do with static members, we can directly call them with the class name and we don't need to create object out of that. So what I will do, I'll quickly add two usage for this one. So if you see here, result one math.add 5,6, and again I'm doing the same thing. Then what we will do, we will write our first decorator. So this method decorator we will use on top of the class method, that means here, okay, on top of this static add. So the first example that we will take is a log method. So what it will do, it will log the parameters as well as the result. So first let us see what will be the signature of a method decorator. So as usual, this will be a function and I will name it. So let us call it as log method. Then it will take three parameters. One is the target, that is the class on which the method exists and on which we are doing the decorator. So I'll mark it as any. Then we will have the property key, which will be of type string, and this is the important one. We'll have the descriptor, which will be of type property descriptor. Then we will add the function body. Here what we have to do, we have to basically override the function. So from where I will get the original function, so I will say const original function equals to descriptor dot value. So what is this? This descriptor dot value will be the function on which this particular decorator is attached. So here if I say log method, this property, this descriptor dot value will give me an instance of this method, so that if I want, I can call original function and this will in turn call this static add method. Now what I have to do, I have to modify the definition of this function, but we have to still keep the original function intact, right? So for that, what I will do, I will say descriptor dot value equals to function. So now what I am doing, I took a copy of descriptor dot value and assigned it to original function. Now what I am doing, I am overriding the value of descriptor dot value with the function definition of my own. Then what we will do, we will pass the arguments which will be of type any array. So we have already seen this in context of the class decorator. Then here I want to do two things. I want to log the parameters, the function arguments, as well as the result. So here what I will do, I will say console.log. Then I will say calling, we will name it as property key. We will say property key, then with arguments, then I will say args. Then what I will do, I will return the descriptor, because this is the value that we have modified. So if I run this one, and before that I will save it, then I will run this one. So I will say method decorator.ts. So if you see here, it is saying calling add with arguments 5,6. This add is nothing but this function, and this argument is these two arguments that we are sending. So we are able to access the method name as well as the arguments. Then what we can do, we have to actually call the method, otherwise we will not get the result here, right? Because we are not doing anything, we are not calling the method, we are simply overriding the method with a console log statement. So what we have to do, we have to call the method. So I will say const result equals to original function dot apply on this context and pass the args. So what will happen? This original function is this function. It will be called with this argument and the result will be stored in the result value. Then we can say console.log and I will log the result. Then what we have to do? We have to return the value. So I'll say return result. Now if you see, we have one log calling add with argument 5 and 6 and it results in 11. So what essentially we are doing? We are tracking which method has been called and with what parameter it has been called and what has been the result of that particular operation. So with this log method, we are able to track this. And how we are writing the method decorator? So we have some parameter. Most important one is this property descriptor. This property descriptor contains a key called value which contains the instance of the function. Now we are overriding that particular descriptor value with our own function, and during that we are calling the original function and storing its value, and after that we are just doing a console log. So this is how you can write a method decorator in which you keep a original copy and you write it with your own implementation, but somewhere in between you have to also call the original method. So this is the whole idea of a method decorator. So let us take one more example. So there is a concept called memoization in JavaScript or in TypeScript, in which what will happen if you pass the same argument to a function, instead of doing the calculation, it will return your cached value. And if the arguments are different, it will do the calculation and it will return you the fresh value, and also it will store that value in the cache, so that next time if you get the same argument, instead of doing the calculation, it will return you from the cached data. Here in our example, it is just simple addition or simple multiplication, right? But in real world, it might be a complicated calculation, it might be a heavy database call, or it could be a heavy network call, right? So there are few things that you want to cache at your application level, so that you don't have to always go to the source to get the value or always to do the heavy computation task. So here let us assume that a plus b is a heavy computation task and I want to memoize this. That means if I pass the same argument, instead of actually doing the calculation, it will return me a cached value. I don't want the calculation to happen again and again if I am passing the same arguments. So here if you see on line 24 and 25, this add I am passing 5,6 both time. So only once it should do the actual calculation, and the second time or third time and onwards it should return me the cache value as long as the parameter remains the same. So what we will do, we'll write a decorator called as memoize, and what parameter it will take? Of course it will take the same parameter as that of the log decorator, and we will add the function body, and here I will add this decorator. Now what we will do, we will borrow this line. So this line remains the same. We will keep a copy of the original method. Then what we will do, we will write our own version of the method that we want to implement. So here first what I want to do, I want to have a variable called as cache in which I will store the arguments versus its result. So what I will do, I will create a map. This should be done above this line where we are updating the function value. So here what I will do, I will say const cache equals to new map. This map will be of type string comma any. So here string, I will store the stringified version of the parameters, and in the result I can store any value. It could be string, it could be number, it could be boolean. So I am keeping the options open. Then coming inside to this function, first what I will do, I will say const key equals to json.stringify args. So here I am getting the key which is the function arguments. This key I will use in this cache map. So what I will say, if cache dot has this particular key. If the key already exists, then what I will say, I will add a console dot log. I will say returning from cache, okay, and I will return cache dot get of the key. If this is not the case, then what I will do, I will say const result, and here I will call the original function. So original function dot apply and this comma args, simple. Then cache dot set key comma result, then return result. So if you see here, we are not always calling the function. We are calling the function if the cache key doesn't exist. If the key exists, we will return it from the cache. If it doesn't exist, we will do the actual calculation. That means we'll call the original method, then set it in the cache and then return the value. So what I will do, I will add a log here, console.log calling original method, so that we will know from where we are getting the result. So if I save this one, if you see, it says calling original method, then it says returning from cache. Or I will do one thing, let us comment out this log method, then we will see calling original method returning from cache. So if I call this method again with the same parameter, what will happen? It will again return the value from the cache. But if I change the parameter, say for example, I'll say result 4 and 5 and let me say 7, right? So what will happen? First it called the original method from this 5 comma 6, then again it saw the same arguments. So what it did, it returned from the cache. Again it saw the same argument, so it returned from the cache. Next it saw a different argument, so it again called the original method. So if I call this method again with the same parameters, what will happen this time? This time it will return me from cache. So this is the basic concept of memorization, and what we are doing, we are using decorator to memorize our output or our return based on the arguments that we are sending. So this is a very powerful optimization technique, and we have simplified this with the help of decorators. So this is all about method decorator, and with this we have completed the concept of decorator. We have discussed class decorator, we have discussed parameter decorator, and we have discussed about method decorator. This completes the concept of decorator in TypeScript, and from next video onwards we will check practical implementation of this decorators. So I will see you in the next video, and if you have any thoughts, feel free to put it in the comment box. Do like, share and subscribe to the channel, and I'll see you in the next video.